The acceptance of mathematics as the universal language is a fact of great significance in the scientific world. This universal language aids us in deciphering the complexity of nature and understanding the workings of the universe. Mathematical constants are among the foundational elements of this universal language, and one of these is the number pi. Pi, obtained by dividing the circumference of a circle by its diameter, is a constant. This number plays a fundamental role in geometry, trigonometry, engineering, and many other fields. However, the mystery of pi is not limited to being just a number. In fact, as we delve deeper into the realms of mathematics, it becomes even more complex. Exploring this mysterious world of the pi number is embarking on a fascinating journey through mathematics. The discovery of the pi number dates back to ancient times in the history of mathematics and has been studied by many civilizations and mathematicians. The earliest approaches regarding this number were made by ancient civilizations such as Egypt and Babylonia. These civilizations observed the relationship between the circumference and diameter of circles. The Rhind papyrus, found in Egypt and written around 1650 BCE, contains mathematical problems, including a formula expressing the relationship between the circumference and diameter of a circle. However, the exact value of pi is not stated in this formula. Nevertheless, the Egyptians recognized the existence and significance of pi. Babylonian mathematics also conducted early studies related to this number. Babylonian tablets contain solutions to various geometric problems and calculations related to some circles. Among these calculations is the calculation of the relationship between the area or circumference of a circle and its diameter. For example, some calculations on Babylonian tablets indicate that the value of pi is approximately 3.125. Although this value does not precisely match the exact value of modern pi, they came remarkably close. During the ancient Greek period, some significant developments occurred regarding the pi number. Greek mathematicians examined the relationship between the circumference and diameter of circles and recognized the existence of pi. Although the exact value of the number was not determined during this period, work was done on its approximate values. Archimedes, a prominent Greek mathematician who lived between 287 and 212 BCE, attempted to determine both an upper and lower bound for pi. Using polygons that bound the circumference and diameter of a circle, Archimedes calculated the value of pi. He estimated the value of pi more accurately by using more complex polygons. Archimedes' work on this matter was an early and important step in calculating the approximate value of pi. Other Greek mathematicians also dealt with the pi number. For instance, Eudoxus, an ancient Greek philosopher and mathematician who lived between 408 and 355 BCE, divided the circle into approximately equal parts using polygons to calculate the approximate value of pi. In ancient China, studies regarding the pi number were conducted, but not with the detailed approach developed by ancient Greek mathematicians. The Chinese utilized an approximate value for pi and performed practical calculations accordingly. For instance, in the 3rd century BCE, the Chinese mathematician and philosopher Mozi accepted the approximate value of pi as 3. Throughout the Middle Ages, mathematical studies regarding the pi number continued. However, during this period, the exact value of pi was not fully determined, and mostly, work was done on its approximate values. Due to the lack of precise information about the exact value of the pi number during this period, mathematicians developed various methods to calculate pi more accurately. Throughout the Middle Ages in Europe, the use of Hindu-Arabic numerals became widespread. These numerals facilitated mathematical calculations and enabled the computation of pi. Particularly during the Middle Ages, Islamic mathematicians made significant contributions to the study of the pi number. They embraced ancient mathematical traditions such as Greek and Indian mathematics. For example, the Persian mathematician and scholar Al-Khwarizmi calculated approximate values of pi and used pi in trigonometric calculations. In Europe, various methods were developed to calculate the value of pi. For instance, some mathematicians attempted to find the approximate values of pi using infinite series. However, most of these methods did not provide the exact value of pi. Ludolf van Sullen, a Dutch mathematician in the 16th century, is known for his work on calculating the decimal places of the pi number. He made a concentrated effort to find the exact value of pi and calculated the longest known series of pi at that time, accurate up to 35 decimal places. This was a remarkable achievement at that time and contributed to a better understanding of the exact value of pi. Van Sullen's calculations demonstrated that pi is irrational and does not have any regular pattern. The efforts to calculate the pi number were part of significant advancements made in the fields of mathematics and trigonometry during that period. His work contributed to a better scientific and mathematical understanding of the pi number and its accurate usage. Throughout the New Age, the development of mathematical analysis played a significant role in the calculation of the pi number. Particularly in the 17th century, mathematicians' studies on infinite series and limits enabled a more precise calculation of the value of pi. During this period, mathematicians such as Leibniz and Newton developed concepts of integral and derivative and utilized these methods in calculating pi. Throughout the modern age, numerous new mathematical methods were developed to calculate the value of pi. Particularly, the use of infinite series enabled a more accurate approximation of the value of pi. During this time, John Wallis facilitated the expression of pi using an infinite product series. Leonhard Euler, one of the most significant mathematicians of the 18th century, made many important contributions regarding the pi number. He proved pi's irrationality and extensively studied its mathematical properties. Additionally, Euler's work on pi had a profound impact on various fields such as trigonometry, analysis, and number theory. Among Euler's contributions to pi, his efforts to prove pi's irrationality hold significant importance. Euler demonstrated that pi cannot be expressed as a fraction and has an infinite decimal expansion, thus making a substantial contribution to the mathematical understanding of pi. Furthermore, Euler thoroughly examined the role of pi in trigonometric functions, expanding its usage and contributing to a deeper understanding in various fields. Euler's studies on the pi number are considered a significant milestone in the history of mathematics. Pi, being a constant with profound mystery in both mathematics and science, holds importance in many aspects. In the recent era, the development of computers and computational technology played a crucial role in calculating the decimal places of pi. Particularly in the 20th century, computers were able to calculate pi's decimal places up to millions or even billions. This advancement enabled a more precise determination of pi's value and its utilization in mathematical studies. The symbol for pi, derived from the Greek letter pi, was introduced by the Greek mathematician William Jones in 1706. He chose the symbol pi as it represents the first letter of the Greek word perimetron, meaning perimeter, which relates to the relationship between the circumference and diameter of a circle. Jones's adoption of this symbol contributed to the widespread usage of pi in scientific and mathematical literature. Hence, the pi symbol is universally accepted today to represent the pi number. Pi holds significance in various fields of mathematics. For example, in geometry, we use pi to calculate the area or circumference of a circle. Similarly, in trigonometry, pi plays a crucial role in measuring the period of sine and cosine functions graphs. Pi is also utilized in mathematical areas such as analysis and differential equations, appearing in various calculations and formulas. In engineering and physics, pi is frequently used as well. In fluid mechanics and hydraulic engineering, pi is used in calculations such as the speed and pressure of flow within pipes. Pi plays a significant role in applications such as the movement of fluids and the design of pipe systems. In electrical engineering, pi is used in calculations involving the inductance of circular coils or the capacitance of circular components. Additionally, in electrical circuits and radio frequency engineering, pi is used in calculations involving wavelength and frequency. Moreover, pi is utilized in signal processing fields for waveform analysis and frequency calculations. For instance, the frequency of a sinusoidal waveform is related to the distance between its peak points, and pi is involved in such calculations. In the field of mechanical engineering, the analysis of circular motions and kinematic calculations involves the pi number. Such calculations are utilized in areas such as the rotation of wheels, the design of gear systems, and the analysis of rotating systems. The exact value of pi is an irrational number with an infinite decimal expansion. However, it is commonly approximated as 3.14159. The precise value of pi extends infinitely without a predictable pattern or repetition in its decimal places. Therefore, the exact value of pi cannot be expressed, and it is generally represented with fractional or radical expressions. Computers and mathematical algorithms are employed to determine the decimal places of pi with greater precision. Nowadays, pi has been calculated to millions or even billions of decimal places. However, in practical terms, approximate values like 3.14 are often used because this level of precision typically satisfies requirements and simplifies computational processes. Srinivasa Ramanujan is one of the most renowned Indian mathematicians of the 20th century, recognized for his work on the pi number. Ramanujan discovered an infinite series expression for pi, sparking significant interest in the mathematical world. Particularly in 1910, in an article titled Fractional Expressions of Modular Forms in Dirichlet series, he expressed pi as an infinite series of fractions. This series expression enabled pi to be expressed in a new manner, deepening mathematicians' understanding of the pi number. Ramanujan also examined the fractional approximation of pi. His studies contributed to a better understanding of pi's irrational nature and aided in calculating pi's infinite decimal places with greater accuracy. Ramanujan's work on the pi number has had a significant impact on the world of mathematics, providing a deeper understanding of the nature of pi. His studies further emphasized the role of pi in mathematics and contributed to a better understanding of its mystery. The exact value of this important number is not known precisely. Despite computers and mathematical algorithms calculating billions of decimal places of pi, the last digit of pi remains uncertain. This uncertainty highlights the mystery and mathematical complexity of pi. The designation of pi as the most important number in the universe is based on fundamental reasons. This number represents the relationship between the circumference and diameter of a circle. Circles and similar shapes are commonly found throughout the universe. Therefore, pi is considered the fundamental geometric summary of many natural phenomena found across various fields in the universe. Pi plays a significant role in mathematical models and representations of many natural phenomena, from the movements of stars and planets to the behavior of waves and electrons. It underpins many concepts and theorems in mathematics, such as trigonometry, analysis, and differential equations, symbolizing the complexity and beauty of mathematical discoveries and connections. Due to its mathematical and universal connections, pi is considered an indispensable tool for understanding the mysteries of nature and explaining the fundamental structures of the universe. In 2019, Japanese mathematician and computer scientist Emma Haruka Iwao broke the Guinness World Record by calculating pi to 31 trillion digits. Pi, with its mathematical and universal connections, serves as an indispensable tool for understanding the mysteries of nature and explaining the fundamental structures of the universe. Don't forget to subscribe for new videos and more scientific content.